Data warehouses as a whole have been around for quite a long time. How we're storing stateful data, how we're looking at stateful versus stateless. But one thing we haven't seen all that much is data warehouses and a data warehouse architecture built on Kubernetes with a platform engineering mindset in play. And that's exactly what we're going to be talking about today. My name is Michael Levan.
My name is Kristina Devochko.
And we have Yellowbrick on today. How's it going, Mark? How's everything on your end? Hopefully, the new year is starting off fresh and good.
It is. Happy New Year to both of you. Hi, Michael. Hi, Christina.
Hello, hello. So, jumping right into the conversation here, Yellowbrick stood out to Christina and I because it's built on Kubernetes. And, one of the things that we'll obviously be talking about throughout this, which one of the things that I thought was really cool was using CRDs and Kubernetes operators to interact with SQL, which if anybody else is doing that, I don't know of it. But that was really, really cool. That was something that really stuck out to me. So thank you so much for joining the show. Really appreciate it.
Thanks for inviting me.
Absolutely. So, history of Yellowbrick. Let's hear it. I mean, of course, everybody wants to hear the overall history, but I think what everybody is also really excited about from an engineering perspective is why build it on Kubernetes?
Yellowbrick was founded back in 2014, so we're fairly late stage in the startup sense of the word. But Yellowbrick came about because there was a gap in the market. There was a real problem in the data warehousing industry going back kind of 10 years. And we were reaching the limits of what the storage technology at the time was capable of. Of course, every database, every data warehouse is founded on the storage layer for persisting data, of course. But at the time, we were seeing the advent of new solid state drives coming into the market. And database companies at the time were looking at how could we exploit the high bandwidth, low latency capabilities of SSDs in a database setting, in a context. And what we found at the time was the processor architectures and the buses at the time, the memory wasn't really suitable. There was an impedance mismatch between what the storage could do that was emerging and what the hardware at the time could do. And so Yellowbrick was founded on the proposition of solving that problem, of removing that impedance mismatch to get the full bandwidth and latency capabilities of the new solid state storage and power very, very fast database analytics using that. So that was kind of the rationale for founding the company. And then over the years, what we did was build first a data warehouse that was really geared around our own hardware. As I mentioned, the hardware off the shelf at the time in terms of the processors, et cetera, really wasn't up to the task of dealing with the vast swathes of data you wanted to pull off these new storage devices. And so we had to go out there and effectively build our own hardware. Well, the good news is over the last 3 to 4 years, a lot of the hardware has caught up, particularly in the cloud. And so what we did over the last 3 years or so is move beyond selling a data warehousing product that runs in our own hardware in a customer's own data center to something that was software only and deployable directly in the public cloud of your choice. And it was also at this point that we decided, well, since the hardware is capable, what else can we use to exploit and get the data warehouse capabilities we want? And this is where the whole Kubernetes side of things came in, and Kubernetes running in the cloud.
Cool. So when did you actually started adopting Kubernetes or migrating to Kubernetes? Was it many years ago, since you started in 2014? That was more or less before Kubernetes actually became a thing and kind of became mature enough to start using for such solutions.
Well, right. Yeah, I mean, I think Kubernetes was really released by Google in 2014, so around about the same time that Yellowbrick was founded. And there was nothing like that we could exploit at the time. And so, we spent those first few years really optimizing our database stack within the context of the operating system as well. And, when you look at databases as a whole, everyone goes off and creates a SQL relational database in very much the same way. There are differences, of course, under the hood, but there's 40 to 50 years of relational database research and development out there that everyone leverages when they build a database. And so what you find is everyone optimizes within the database software stack, but little regard is given to what's happening at the operating system layer on top of which all of that sits. And so one of the big insights and the big drivers towards achieving really, really fantastic performance out of this new breed of storage device was really getting down into the details of their operating system, bypassing a lot of the inefficiencies within Linux, for example. So that we run on top of Linux, we actually run in user space. So we bypass a lot of the Linux kernel, and we've implemented our own device drivers for storage, for networking. We've created our own task scheduling, memory management schemes, all of these that are optimized towards the kinds of data movement and workflows that you expect an MPP, a massively parallel scale out data warehouse to work towards. So that's what we've really focused on, is getting those foundation parts right. Also been interesting over the last 10 years in this industry is the industry's moved with the sort of remarkable things that Snowflake have done, for example, to take what were quite static data warehouses and introduce a huge amount of elasticity and ease of use into. It was quite a revolutionary kind of thing going back again 10 years. And so when we were looking about adopting cloud-based data warehousing and migrating to the cloud, we wanted to tap into that elasticity. We wanted to take full advantage of the resilience that the cloud can bring and the flexibility and the agility that it brings. And to do that, we wanted a framework to help support that. And that framework we chose was Kubernetes, of course, because we're a database company. Our core business is not building, general purpose container orchestration frameworks at all. It's building and selling a data warehouse. And so it was kind of a no-brainer to take something like Kubernetes and start to build Yellowbrick on top of that, or take what we've done and migrate it within that environment. So that's what we've done. But we also had an eye on the typical database administrator knows nothing about Kubernetes, and so how can we kind of provide a user experience that a database administrator would be familiar with without exposing a lot of stuff that they don't need to care about.
That's the interesting part. I mean, there's obviously many interesting parts here, but the thing that really sticks out to me the most is very recently, like 2-3 years ago, I was having conversations with people where they're like, databases can't run on Kubernetes. Kubernetes is for stateless applications only. And again, 2-3 years, very, very recent. Yet, y'all have been doing this for many years at this point, and literally everything for your data warehouse is built directly on Kubernetes. So it's very interesting to think about, outside of the product itself, really what Yellowbrick is doing is paving the way to show people that you can use databases and you can build for databases directly on Kubernetes. Because again, this is something that there's still a lot of folks out there right now that think that, Kubernetes isn't good for stateful based applications. It's not good if you're running a database, etc. So outside of Yellowbrick building a data warehouse, you really are paving the way to allow people, or rather to show people, hey, no, you can build database on Kubernetes. We're building an entire company on it.
There are certain aspects to a data warehouse and the types of use cases it's put to that actually makes that leap from stateless to stateful application building in Kubernetes a little bit easier. You think about how you query a data warehouse and what you use it for. You're writing SQL analytics queries that are typically doing big aggregations on historical data, right? And so the first thing is you talk about you need some persistent state within your Kubernetes application. Where do I store that? And because the data within a data warehouse doesn't change very much, you tend to just append new records, new closed transactions, new point of sales things happen when someone swipes their credit card, and that transaction doesn't change. It gets pushed into the history and so on and so forth. And so one of the nice things is that makes things a little bit easier is we can persist that in something like cloud object storage. All of our data within Yellowbrick, the vast majority of it, we have customers running at the petabyte scale, that gets stored in S3 on AWS, for example. So when it comes to sort of persistent data that we need to update frequently, the volume of that is much, much smaller. We're talking about metadata at this stage. So you can imagine our architecture is all of our data is stored within an object store layer. We have metadata, effectively the database catalog. When you run a query, the query planner references the metadata catalog and decides what it needs to read from S3 to address the query. So in some ways, we've simplified the whole sort of storage and the persistent volume claims picture within Kubernetes world to do data warehousing. So that's been very helpful. I mean, a few of the other things that we were really at top of our mind 3 years ago were, well, we've done all of this optimization in the at the operating system level and in the database software stack, if we start to containerize this stuff, throw it into Kubernetes, are we still going to get low-level access to the underlying hardware that we need in order to maintain the performance? I mean, one of the key design goals was, as we move from our own hardware into cloud hardware, we must be performant. We must maintain that performance advantage over the competition. And so one of the things that was really interesting to see is we really didn't have a problem with the performance gap between what we do on our own hardware and what we do in the cloud now in a software only context. And Kubernetes isn't a barrier to accessing the low level network interface cards, accessing the PCIe devices on these cloud instances, et cetera, et cetera. It's been quite a journey, but we've had a lot of thought and a lot of help along the way in terms of our use cases.
That sounds really cool. And like to what Michael also said, I think by setting an example, by like sharing your story, you kind of help to maybe show for the rest of the community who have been thinking quiet for some years that it is scary to run stateful workloads on Kubernetes, for instance, that it is possible and that it works. But what I think is more interesting here is to ask a sneaky question, because I think that the question about challenges and what you have learned from, what have you failed on during this journey? Those who may have been doing many of these things, being one of the first companies, maybe just taking the whole running stateful workloads on Kubernetes thing at scale. I guess it was not all perfect and rainbows and unicorns and 100% error-prone solutions. So that's the most interesting, what I feel for engineers is like, have you experienced any challenges and what have you learned from this journey as well?
I would say there are probably two areas that stick out to me. We were changing our product strategy 3-4 years ago. We were deciding we're going to move away from our on-prem hardware and then decide to deploy our software in the public cloud of a customer's choice. So typically that's, AWS, Azure, or Google Cloud. And so one of the other things that attracted us to Kubernetes was, well, hey, this is kind of a portable runtime. We can speed up the deployment on different flavors of cloud by exploiting the fact, once we containerized our software, once we pushed all the dependencies together, moving this software from one cloud to the another is going to be fairly straightforward. And that was extremely naive. And partly because we'd also made the decision that we wanted to use the cloud provider's native Kubernetes services. So EKS and AKS or GKE. And we thought, hey, yeah, that's fine. It doesn't matter. This stuff will run anywhere. We'll just throw it on these systems and off we go and profit. And of course, that hasn't been quite the case. And it has speeded up our deployment on different flavors of cloud. There's no doubt about it compared to doing bare metal implementations on these different things. But there were lots of different idiosyncrasies that you see. And one that stands out is EKS and its CNIs, the way it handles and manages network interfaces within that environment. There were crazy things that took a while to figure out. We were having real scaling problems. Within Yellowbrick, when you create a Yellowbrick system, you can create compute clusters, which are elastically scaling sets of EC2 nodes in the case of AWS. And you can run queries in parallel over these. Our query optimizer will parallelize queries and they run very quickly and so on and so forth. But what we were finding is that as we spun up compute within AWS on EKS would be very aggressive and be very greedy at grabbing IP addresses, for example. And it still does that today. And in fact, I was at AWS reInvent at one of the EKS sessions just about a month or two ago, back in November. And one of the EKS developers was there, put their hands up, and they asked the question, what's one of the biggest problems that you see running in EKS that you've come across? And I put my hand up and said, greedy acquisition of IP addresses by EC2 nodes. And everyone else put their hands up and said pretty much the same thing as well. And so you've got to be very careful because you get to the point where you exhaust the IPs within your CEDAR block, within your VPC, and you can't scale anymore. And so you have to kind of do some tuning at that level on the one hand. The other one I mentioned was some of the design decisions we made early on that we've come to regret and that we've had to go back and fix. And I mean, this is just typical of any software engineering exercise, and it's partly grounded in the legacy that you bring with you, the baggage you bring with you in any software stack, right? So we already had kind of a cloud service ourselves with a whole bunch of workflow, orchestration, monitoring going on, an entire framework around that. And I think one of the mistakes we made was we want to use this to manage our entire Kubernetes state and run Kubernetes in the context of all of this other framework that we've already got. And so we didn't choose operators to start with. We were manipulating CRDs directly. We had the situation where we had a configuration management database that could get somewhat misaligned from the state of Kubernetes. So we had this split brain potential issue going on, right? We had a whole framework from the outside looking at Kubernetes, trying to keep track of what the Kubernetes cluster was doing, and then reflecting to the user interfaces, the state of Kubernetes. And of course, there's plenty of opportunities for things to go awry there. And so what we've subsequently done is throw that legacy part away, go pure Kubernetes, use operators to control the state of the system, to provide indications of events in the Kubernetes system, and go, the single source of the truth is Kubernetes, if that makes any sense whatsoever.
As you were deciding, hey, we're going to go on Kubernetes, were there any other conversations that came up around, like, for example, in 2014, 2015, were there conversations around, like, should we use Linux containers over another orchestrator, or, more recent questions or conversations? Was there like a Nomad and Kubernetes conversation? And like, as you were building this whole thing out, were there different conversations on whether you should be running on Kubernetes or not?
No. I think once we've made the decision to go with Kubernetes, we really decided, well, the first deployment we're going to do is AWS. It's the largest cloud provider on the planet, effectively, in terms of market share. It's still the most mature in terms of its Kubernetes support. And so we really focused and aligned our product strategy and our development plan around deploying on EKS first. And so that meant, deciding on what the armies that we're going to use for the guest operating systems, and the container runtime that comes with those. We really decided to fit very closely in with what AWS offered. And then, with then thinking, hey, it's not going to be that much of a leap when we move to Azure next, and not much of a leap when we go to Google next. But as I said, all of these cloud providers have different idiosyncrasies that we've had to kind of address. But Kubernetes has allowed us to address those. And on the whole, 80 to 90% of the code that runs on AWS, Azure, and Google Cloud is the same. And I think if we had our time again, we'd still do the same. But as I said, we would have had a clean sheet and not dragged in legacy code that's probably caused more problems in the past than we'd have hoped.
When you were running the entire service on-prem, I believe you mentioned that in the beginning, right? Where from the start of Yellowbrick, you were running everything on-prem, your own data centers, right? Was there any conversation about like running everything with Kubernetes on-prem, like bootstrapping with kubeadm, for example, and running everything out of the data centers, but, with Kubernetes, but on-prem versus in a cloud provider?
The short answer to your question is no, we weren't going to do that. So you're quite right. So back in the day, we had a cloud service that was running on our own bare metal in our own data centers with all this legacy software infrastructure that I mentioned earlier around it. And, we thought we'll just take that legacy control framework, the control plane, basically plug Kubernetes into it in the cloud, and we're off to the races. Now, what we're going to be doing moving forward is we're going to be taking everything we've learned from running Yellowbrick on Kubernetes in the public cloud, and we're now bringing Kubernetes back home. So we're now starting to deploy Kubernetes on our own hardware and taking everything that we're doing in the cloud and bringing it to on-prem. So from a product strategy perspective, it's really about how can we build a cloud-like data warehousing experience, but in a Kubernetes cluster that runs in a customer's own data center. So you want all the goodness of elasticity within the confines of the fixed footprint of the hardware that you have in your own data center, but multi-tenancy, resilience, et cetera. And that's what we're working on. So this year, at the end of this year, we'll have kind of a big unification of Kubernetes running basically everywhere, on-prem and in every public cloud. So we're going to get there, but we've kind of gone around the houses to get there.
That's awesome. Very cool. And just one more question for you about that. As you're thinking about bringing that on-prem, it also opens up customers to be able to run this hybrid cloud model, right? So like if they want to do something with like AWS Outposts or Azure Stack HCI or something, or even like, build their own where they're running some environments on-prem for Yellowbrick, and then they're also running some environments in Azure or in AWS or wherever. So it's really cool that it gives the ability for customers to have this hybrid model for their data warehouse. I'll definitely be interested to hear about that from y'all if anybody decides to do that.
Yeah, and in fact, we have that hybrid setup amongst our customers today. So our customers that started off buying our on-prem hardware, in many cases, they're still running that hardware in their own data center. But as they get new workloads coming on board, they want to quickly spin up capacity in the cloud of their choice and push new workloads there. And so quite a lot of our customers are running Yellowbrick in more than one place. And they can take advantage of the fact that we can replicate data from one to the other, for example. So you can move data between your on-prem environment and the cloud very easily. And they're using it for a range of workloads and cases where, it could be just sort of ad hoc discovery exploration workloads. They've got a new idea for an analytics product. They want to quickly spin up some resources in the cloud, move some data from their on-prem production system into the cloud, try some experiments out, then shut it down, throw it away, and not have to pay for it again, right? So Yellowbrick running on Kubernetes provides that flexibility that, they can spin on a dime and crank that capacity up in the cloud and then switch it off when they don't need to. We've got other use cases where they're using the cloud version for disaster recovery, where they're keeping a small instance of Yellowbrick running almost like a pilot light. They're continuously copying data, backing up data to Yellowbrick running in the cloud. In the event of some major disaster or business continuity problem, they can switch over and then run their business from Yellowbrick in the cloud. And we have customers doing that today.
That's awesome. Very cool.
Cool. I think like especially when it comes to data, I guess on looking for an on-prem solution is kind of something that many customers may be interested in. But of course, compared to like running it in public cloud, I'm wondering how much more effort that would need to set up a whole data warehouse and operate it on-prem on Kubernetes. I guess that would require good competence from the Kubernetes administrators on the customer side, because I assume that you are offering the Yellowbrick solution as, in a way, a managed service where you manage kind of the underlying platform. So customers would not need to think maybe much about that, but it would be a totally different story on-prem.
You're right, but another design goal that I mentioned kind of earlier in our discussion was we don't want to expose any of that Kubernetes complexity to end users unless they want to take advantage of it or use it. In a sense, what we do is provide an as-a-service experience, a data warehousing as-a-service experience, but the customer runs it itself, which is kind of a contradiction in terms. And what we've done is a lot of effort into the kind of day zero, day one operations when you install Yellowbrick in the public cloud or on-prem when we get to the Kubernetes version there. It's a very, very straightforward and simple experience where there's a very happy path where you don't have to worry about setting up Kubernetes. As you basically, if you quickly walk through how you install Yellowbrick in, say, AWS on Kubernetes, you can choose to bring your own Kubernetes cluster or get us to spin one up. You can choose for us to create the entire network infrastructure around Yellowbrick, or you can bring your own VPC, for example. So this installation process today, it uses CloudFormation. We're actually writing a brand new installer that gets rid of CloudFormation because it's not very good. But what CloudFormation will do in AWS, it will spin up a Kubernetes cluster, create the node groups, put all the load balancing in place, create the subnets, security groups, do all of that. And at the end of the installation process in AWS, you're presented with a URL to our web-based UI. And from there on in, you don't need to think about Kubernetes. It's there under the hood, powering this thing, providing the elasticity and resilience and whatnot. But if you don't want to, you don't care. You just crack on and run analytics and not worry about it.
That's how it should be. For any product out there, there shouldn't be a hard requirement for you must know Kubernetes. It should be, hey, you don't have to know Kubernetes, but just in case you do, here's the installer and you can put it on, your on-prem environment, or, you don't even have to worry about it. That's really, really cool. And speaking of which, we only have a few minutes left here, but I did want to touch on the thing that I was probably most excited about was the ability to manage SQL with Kubernetes operators, right? Or custom resource definitions, managing that whole aspect of SQL and writing the SQL queries, et cetera, with a Kubernetes based API. So maybe we could touch on that a little bit. And by the way, for everybody listening, we will have a part 2. We will have a second episode with Yellowbrick where we go over the entire infrastructure and how Yellowbrick is set up. So I'm sure we'll be diving more into this question in that second episode. But Mark, if we could touch on that a little bit to wrap up here, that would be great.
Yeah, one of the design goals for moving towards Kubernetes and adopting Kubernetes was we don't want customers to have to worry about kubectl or worry about Helm charts or worry about CRDs or any of that. We just want a business analyst or a data scientist to be able to go to the console, click a few buttons, spin up some Yellowbrick compute capacity, run their analytics, shut it down. And that's great. That's what we were looking for. We wanted to avoid the command line. But if the command line was needed, because it often is obviously for scripting and things like that, we wanted the language of choice of manipulating the compute resources and the storage within Yellowbrick to be SQL. SQL is the de facto standard language for every database administrator. Most business analysts on the planet know it. A lot of data scientists these days do as well. We wanted to use that not only as a language to run analytics and get insight from your data, but the language for creating compute capacity, for destroying compute capacity, for elastically expanding. And so what we did was expand the SQL grammar within our database software to have these new directives that would allow one to easily create a compute cluster of n EC2 nodes. And what really would happen behind the scenes is rather than our database engine going off and processing that query at the end of the day becomes a Kubernetes API call, which allocates the necessary resources. We have a cluster autoscaler in place, which when you ask for that many nodes for that particular cluster, Kubernetes goes off and autoscales that up for us. If any of those things fail, those nodes fail, it gets an alternative node and brings it into the cluster. So it's those kinds of activities that we've done. And I have to say, I don't think many folks in the data warehousing industry have done that. And I think our customers are getting a lot of value and appreciate the simplicity that brings.
Very, very cool. Yeah, and I'm excited to dive into that more into part 2. That'll definitely be a cool conversation. So before we wrap up here, Mark, Christina, any final last thoughts?
Maybe a good question to round up with. If you could name maybe the top things that engineers can think about based on your experience and your journey in order to succeed with running stateful workloads on Kubernetes. If it's one top thing or two, you choose how many, but if you could name something to inspire engineers that it's possible.
One thing that does stand out is this idea of trust Kubernetes. Trust its ability to monitor its own state and use that as the single source of the truth. Don't make the mistake we did originally of thinking, hey, we're going to have to maintain the entire state of our system separately from Kubernetes, because you get that kind of split brain issue. So we're putting more and more of our trust in our product in Kubernetes, its ability to maintain and correctly reflect the state that it's in. And then from that, derive what we need to do and what we need to present to an end user, for example, about the health of the system, for example. That's probably one of my biggest takeaways. And perhaps the other one comes back to the idea of beware of idiosyncrasies of the cloud provider's own managed Kubernetes services. Maybe this is an obvious thing to say, but there are differences, and some of those differences can get you and cause you problems. So it's very easy to get 80% of the way there, but it's that remaining 20% when you're moving to one of these cloud provider managed services that becomes problematic.
Well, I think that if you would like to see how this looks like to request, for example, compute capacity with SQL, you could check it as fast as just checking it on the website of Yellowbrick, because when I checked it for the first time, I was like, whoa, what am I seeing here? Is it SQL? What's happening? So I think that looks very cool, and I'm super excited to learn more about the technical side of things and the architectural side of things in the second part.
Fantastic. And I just finalize that with, if any of your viewers or listeners are interested in trying Yellowbrick out, please do go to our website. There's a free trial there that you can log on and play instantly with Yellowbrick and get a flavor for what we're talking about.
Awesome. Very cool. Well, Mark, all the team at Yellowbrick, thank you so much for hopping on the podcast. Really do appreciate it. And for all the listeners, of course, as always, thank you for listening. And remember, Part 2 will be coming, and we'll be talking about the overall architecture of Yellowbrick. So if you're in an organization where you're thinking about deploying database on Kubernetes, if you're thinking about deploying data warehouses, if you're thinking about just how stateful workloads can work as optimally as possible on Kubernetes, those questions will definitely be answered in part 2 of this. So thank you so much for listening. And Mark, all the team at Yellowbrick, thank you so much for coming on.